Hey guys, S1700. The purpose of this video is just to get better at systems of linear equations and matrices. Problems are going to be just a little bit tougher than what we've seen before. Still doable, but yeah, let's just get better at it. Okay. So question, and this will be uploaded. This handout will be uploaded to Blackboard, so you'll have access to it. So anyway, let's read the problem. An actual test question from the GMAT. Um, so a rabbit on controlled diet is fed daily 300 grams of mixture of two foods, food X and food Y. Food X contains 10% of protein. Food Y contains 15% of protein. The rabbit diet provides exactly 38 grams of protein daily. How many grams of food X are in the mixture? So when we introduce and define the variables here, what we do is usually we come to the last sentence and we see that we are being asked to find grams of protein in food X. So I'm going to let X be the grams of protein in food X. And I'm going to let Y be the grams of protein in food Y. So we can go to the last sentence and we can get a lot of information about, what we're being asked to solve for. So it makes sense if we're being asked to solve for grams of protein in food X, then we should let our variables that we're going to solve for represent the answer to the problem. So that's why it's extremely helpful to go to the last sentence in many of these questions and find out what you're being asked to find, because you know that's going to be your variable. Now what we got to do is we've got to go back in and look at relationships. So we can see that a rabbit is on a controlled diet, is fed daily 300 grams. So I know the grams from X and the grams from Y has to be 300. The next thing I see is that the diet provides exactly 38 grams of protein, 10% of that food X, and 15% of food Y is protein. So it makes sense to me that I would have 10% of the total number of grams in X plus 15% of the total grams of protein in Y have to be the total grams of protein, which is 38. Now guys, that's the hard part. The next part's simple. We put in the coefficients of our system of linear equations, and we turn it into an augmented matrix. Now the next thing we'll do is we'll use our calculator, and I'm going to use this calculator. All right. So the first thing I'd want to do is come into matrix and set up my calculator. So I'll go over to edit, and I need a 2 by 3. So type 2 by 3 and put in the corresponding entries of our problem. Next thing I'd want to do is go second function quit. I want to clear out this home screen. I like to have a blank home screen when I work on things. Now go back into matrix, go over to math. I'm going to scroll down, but what I need is on B, RREF. Okay? Get this over where you guys can see it. When I select that, it kind of sort of copies and pastes that back into the home screen. Now I've got to go get the matrix, so I'll go back into matrix. I got to select the matrix that I set up for this and close it up with the parentheses. What I see now, as I see my matrix, is this first column corresponds to the first column of the system of linear equations. So these are my x's. The second column are my y's. These are my constants. So when I get this response on my calculator, what this is saying is 1x plus 0y is 140. 1x plus 0y is 140. Guys, this just tells me x is 140. Same logic here. 0x plus 1y, let me keep on saying, is 160. Tells me y is 160. So guys, the answer to this question, we need 140 grams of food X and 160 grams of food Y to create a total diet of 300 grams total and to create protein of 38 grams total. All right, but it says how many grams of food X, so the answer here would be 140 grams. That was an easy question, but I'd say more than likely that question is missed quite a bit on the GMAT. Okay, gang, number two. Number two talks about a bank wishing to, I'm not going to read this to you, but I'm going to just highlight it. There's $100,000 in a trust fund that needs to be invested in three sources: bonds, CDs, and first mortgages. The interest rates are given for each of these. The bank wants to have $8,000 annual income from an investment. And I tell you that these rates are not realistic in today's society. For example, CDs, you're not going to get 7% today in a CD. You might get 0.7, but you're not going to get 7%. There's a condition here. The trust, this is going to be the most complicated part of this problem, but we'll address that in just a second. But just like any system of linear equations, we come to the last sentence to see what will correspond with our variables. So we see how much should the bank invest in each source, where the sources are bonds, CDs, and first mortgages. So guys, we see that X, Y, and Z are reasonable variables. So X is going to be the amount in bonds. Y is going to be the amount in CDs. And Z is going to be the amount in first mortgages. Now, guys, when I see this, it's clear to me that I have three variables for this problem, which tells me without hesitation, I know that I have to find information in my problem to create three equations. Well, the very first equation is really simple because it tells me right off the bat here that I need 100,000 total invested. So guys, I know that X plus Y plus Z has to be 100,000. The next one's kind of easy too, because it says that we need to get $8,000 in annual income. So that's the interest from these investments. Well, to calculate the interest from bonds, we take the interest rate times how much we have in there. To get the interest from CDs, we do the same thing. Interest rate times how much we have in there. Because again, this is all based on 1 year. Same thing for the first mortgages. Guys, I need to realize an annual sum of interest of $8,000. Now, the next one becomes kind of tricky, and listen very closely here, because this is something that we run into a lot, conditions like this, investing money. A condition of the trust is that the total amount invested in bonds and CDs, which is X and Y, must be triple the amount in mortgages. Now, if this amount is to be triple this amount, do I multiply this by 3 or do I multiply this by 3? Well, let's just think it through. Let's say that Bob and Mary exist, and Bob has 3 times as much money as does Mary. For me to make these two amounts equal, I have to multiply the smaller amount by 3 to make them equal. So guys, ultimately here, I want 3 times as much money over here as what's over here. So to make these things equal, I have to multiply the smaller amount by 3. It's kind of counterintuitive because this needs to be 3 times bigger than that, but because we're putting this expression in the context of an equation, to make these two things equal, we have to multiply the smaller amount. Now, the next thing you're going to do is you need to transfer this into your augmented matrix, and the first 2 lines, I'm not talented enough to write and speak, but the first 2 lines are very clear. This line down here is not so clear, but remember, in augmented matrices, in augmented matrix form, our first column is x, my second column is y, my third column is z in this situation, and my last column is my numbers. So I know that under my x I need a 1, under my y's I need a 1. For my z's, this z has to get over here on the left side of the equal sign. Well, the 3z becomes negative, and my constant is 0. Now, put this in your calculator, and I went ahead and already did this just to save some time. You can always stop me. You have the power of pausing, right? Well, you have a lot of power, actually. And you can see that I already have this set up accordingly. Now, what that allows me to do, it allows me again to go into matrix, go over to math, come to this RREF, again, reduced row echelon form. Go get my matrix and close it up. And we can see that we get X, which is our bonds of 25,000. This is Y, which is our CDs of 50,000, and our first mortgages of 25,000. Sure enough, we add up to 100,000. Sure enough, we'll get $8,000 interest, and we can see that the amount here and here is 75,000, which is triple the amount in first mortgages. Okay. So use your calculator. We did. So we need I forget now, 25,000 in bonds, 50,000 in CDs, and 25,000 in first mortgages. All right, so that was just a little trickier due to that the sum of those two investments being triple the first mortgages. All right, student saving for college was given $6,000 by her grandparents. Well, that'd be cool. Wish my grandparents would give me $6,000. She invested part of the money in a savings account, earning 3% per year. The rest was invested in a bond that paid 5.5%. How much was invested at each rate? This is going to be a really easy problem because there's only 2 investments. And it looks like we got part in a savings and part in a bond. So we're going to let X be the amount in savings and Y be the amount in bonds. I'll tell you what, guys, if you get one of these on your first exam, you should high-five me. This is going to be pretty easy. Guys, we need the 2 amounts to be 6,000, and we need our interest of 3% plus our interest of 0.055 to be $305. So easy problem here. So let's go into matrix and get this set up. So guys, we have a 2 by 3 here, so we need to change the size of the matrix. So we have 6,000 and 0.03, 0.055, and what do we need? 305, yeah. Now, second function, quit. I know that I just need to repeat what I did right up here with this new matrix A. So I have a key on my calculator that says entry. It's blue, which means I have to hit the blue key first. So now it's going to execute that command on my new matrix A, which is a 2 by 3. And we can see that we put 1,000 in um, all right, so we put 1,000 in savings, and we put 5,000 in bonds. Okay? Yeah. Well, I don't know how that problem slipped in because these were supposed to be more challenging. Now this one is. This one's more challenging. This is a way that you see some of your problems presented too. The Upside Down Company specializes in making down jackets, ski vests, and comforters. The requirement for down and labor and the profits earned are given in the following chart. So it looks like we need 3 pounds of down for a jacket, 2 pounds for vest, and so on and so forth. The time for a jacket, and we make $6 profit on each jacket, $6 in vest, and $2 comforter. Not bad. Okay, each week the company has available 6,000 pounds of down, 275 available. Labor hours, wants to earn a weekly profit of $11.50. How much of each item? So each item is my jacket, vest, and comforter, right? So I'm going to let X equal the number of jackets, Y equal the number of vests, and Z equal the number of comforters. Okay? Now what do we know? Well, we know our total down needs to be 600. We need to know that our total labor hours has to be 275. And we want a weekly profit of $11.50. Well, we get $6 profit, so we're going to multiply that by the number of jackets. $6 profit on vests, so we'll multiply that times the number of vests. And $2 profit on the number of comforters, we'll multiply that. And we need $1,150 profit on these items. All right, so gang, we need to go back in and make it happen. So we have 324,600. And 211,275. And we have 662, 1150. Yeah. All right. I think that's good. Got a second function entry. And from this new one, we have transform. So I'm not going to write all this out, but yeah. Go ahead and be thorough. There may be students that are still trying to learn this. So I need no shortcuts. All right, gang. Looks like we have 50 jackets. And we have 125 vests. And we have 50 comforters. All right, easy stuff. Now, this is a hard problem. This one is. I found this one on a test. I forget what test I found this on, but this is kind of a hard problem. So, a baseball player's batting average is determined by dividing the number of hits by the number of bats and multiplying by 1,000. For example, if a player gets 2 hits and 5 times at bats, then his or her batting average is 400. Partway through the season, a player thinks to himself, If I get a hit in my next time at bat, my average will go up to 250. However, if I don't get a hit in my next at bat, my average will drop to 187.5. How many times has this player batted currently, and how many hits has he had, and what is his current batting average? Now, this is the kind of problem. Hold on, guys. Sorry, the coffee was looking so good. How many times? Okay. Anyway, let me get back on. This kind of problem was really kind of what inspired me to love mathematics as a kid. I was obsessed with sports, and these kinds of problems. I mean, I remember I used to be obsessed with baseball cards, and when I was about 10 or 11 years old, I couldn't figure out how they calculated the ERA, and anyway, I figured it out. I was so happy. Yeah. So anyway, sports is really what kind of inspired me to start learning math. But okay, well, what's going on here? Let's start defining some variables. So how many times has the player batted? Let's let X be the current number of at-bats. How many hits has he had? So let's let Y be his number of hits. What's his current batting average? Well, his current batting average would be X divided by Y times 1,000. And we'll come back to that in just a second. All right, gang. The first thing we have is if I get a hit in my next at bat. Well, if he's currently batted 100, Y times, then when he bats the next time, this is going to be Y plus 1. And if he gets a hit in his next time at bat, then this X is going to increase by 1 to go X plus 1. Now, times 1,000. And he claims that if this happens, his average will go up to 250. However, another condition, if I don't get a hit in my next at bat, then his number of hits will stay at X. But his number of bats will increase to Y plus 1. And if that happens, his average will decrease to 187.5. Now, we got some cleaning up to do, and the very first thing I'd want to do, and I'll tell you what, I'm going to need some more space here. First thing I would do is divide both sides by 1,000. And if I do that, I get 0.250. And the other one, 0.1875. Now, it's going to cross multiply. So this first equation will become X plus 1 equals 0.250 times the quantity, Y plus 1. And then this equation, if I cross multiply, will be X equal 0.1875 times Y plus 1. Now let's clean each one of these up. Let's clean this one up here. So this one's going to be X plus 1 equals 0.250Y plus 0.250. And this one is going to be X equal 0.1875Y plus 0.1875. All right, gang, what I need to do now is I need to get this in a form that's going to work in my augmented matrix. So I need to get all my X's, all my Y's, equal all my numbers. Well, I've got this first one, X, but I want to move this 1 across. And I want to move this 0.25y over here. Well, that's going to become negative 0.250y. And when I subtract 1 from both sides, I'm going to get 0.250 minus 1. Now I can do that in my head. Some of you may be able to as well. I just wanted to show that if you don't have to, just play it safe. If you can't do that, just play it safe. Now this x over here, this negative, or I'm sorry, 0.1875 will move across, making it negative. And the 0.1875 stays to the right of the equal sign. Our augmented matrix here, is this nasty mess. Okay? Now remember guys, these are our x's, these are our y's, and these are nothing more just our constants. Okay? Alright, so let's put this in our calculator very carefully. So second function matrix, I'm going to just deal with matrix A. So we need a 2 by 3. So I need a 1, a negative 0.25, and a negative 0.75. And a 1, and a negative 0.1875, and a 0.1875. Second quit. Now I can go second entry again. It'll keep going through the commands I've done. I need the one above it, so I just hit entry twice. And I can see that I get 3 and 15. Interesting. Okay. So my solution here now this line right here tells me x is 3, and this line right here tells me y is 15. So I want to know how many times has this player batted. Well, the number of oh, I got that backwards, guys. Number of hits should be x. The number of hits should be y, because I set x divided by y, not y divided by x. Could have done it either way. It doesn't matter. So the number of times they've batted is y, so current at bats were 15, and current hits were equal to 3. So the current batting average would be 3 divided by 15 times 100. They're not batting too good, too well. Their batting average is 200. 200, not that great of a batting average, unless you're a pitcher. I mean, if you pitch, you focus on pitching. Now let's see if this works out. So we're 3 out of 15. So if the person gets a hit in the next bat, they're going to have 4 hits out of 16 at bats. So they're going to be batting 250 just as we needed. But if they don't get a hit in the next at bat, they're only going to have 3 hits out of 16. So they're going to have 0.1875. So it does work out. And on to the next problem. Number 6, a clothing manufacturer has factories in LA, San Antonio, New York. Sales in thousands of units during the first quarter are summarized by the production matrix. So gangs, it looks like that this clothing manufacturer is selling coats, shirts, sweaters, and ties. During this period, the selling price of a coat was $100, shirt $10, sweater $25, and a tie $5. The price matrix could be set up as a 1 by 4 or a 4 by 1. Set up an appropriate, this is a complicated problem, guys. This one really, You need to put the kids to bed. You need to turn off the TV. You need to put away your phone. This one's going to take some thought, but it's a good one because it's going to kind of set the stage for you to learn more about this particular type of problem. So set up an appropriate price matrix such that the multiplication of the two matrices has entries with meaningful interpretations. All right, gang, let's just call this A, and let's call this matrix down here B. Now, if I go A times B or B times A, which one of these works and gives us meaningful entries? Well, we all know that A is a 4 by 3 matrix, right? So for us to be able to multiply B, which I'll just call the selling matrix, the price matrix is what they call it, then I need a 3 here and however many columns. Well, I have 4 sources of information, don't I? So this 3 matching up in my number of columns for A and my rows in B, this just doesn't make sense. But if I multiply my B times A, so guys, again, my A is a 4 by 3, then I know that I must have a 4 here. So to set up a 1 by 4 or 4 by 1, clearly this has to be a 1 by 4. Now, just because we can multiply the matrices doesn't necessarily mean that the entries are meaningful. Not only does this 4 have to be the same, the number of columns in B has to be the same thing as rows in A, they have to say the same thing. So if I set up a 1 by 4 matrix, 1 row, times again, I'm not talented enough to multiply these out. So what happens is my row is the price, my columns are the coat, the shirt, the sweater, and the tie. Notice that I have coat, shirt, sweater, and tie. So not only do we have the same number in the 4 and the 4, these things are measuring the same thing, which they have to for us to have a meaningful interpretation. This is LA, this is San Antonio, this is Newark. Now, guys, what I know now is that my product matrix is going to be a 1 by 3. It's going to have 1 row, and 3 entries. The value of the row, the meaning of the row, is going to come from my B matrix, which is the price. The value of the column, the 3, is going to come from my second matrix, which will be LA, San Antonio, in New York. So when I multiply these things out, this is going to tell me the total price of all of the coats, shirts, ties, and sweaters in LA, all in San Antonio, and all in New York. So let's set up our matrices and get this going. Okay. So the first thing, because I'm going to multiply the 1 by 4 first, I'm going to go into the matrix, and I will set up A to represent the first matrix. So it's going to be a 1 by 4. So I need 100, 10, 25, and 5. Quit. Go back into my matrix. Scroll over to Edit. Go to B. And guys, in this case, I need a 4 by 3. So I have 12, 13, 39, 25, 5, 26, 11, 8, 8, and 5, 0, and 12. So gang, now I'm just going to go back. I'm going to go get matrix A. I'm going to multiply it by matrix B. And I know that the total cost in LA is $17.50, San Antonio $15.50, and in New York $44.20. Now guys, this is in thousands of units. So so you know we would multiply that by 1,000. All right? Kind of a tricky problem there, at least setting it up. I don't know how many more problems we got. Okay, good. This is the last one. I was getting kind of ready for this video to end, to be honest with you. Mrs. Goodbuyer, well, that's interesting, plans to buy 100 shares of computer stock, 300 shares of oil stock, and 400 shares of automobile stock. The computer stock is selling for $60 per share. The coil, I think that's supposed to be oil stock, is selling for $38 per share, and the automobile stock is selling for $17 per share. Express the number of shares of stock that Mrs. Goodbuyer purchased as a column matrix. Now, a column matrix just means that we have one column. So we want the number of shares, so we have 100, 300, 400. And this is computer, oil, and automobile. And this is shares, okay? B, express the price per share as a row matrix. Row matrix says we have one row, and in this case 3 entries. So we're going to have 60, 38, and 17. So we have cell, and we have computer, coil, and automobile. Calculate and interpret the entries of A times B. So we're saying this is A and this is B. So guys, when we take A times B, first of all, let's see if we can even multiply these. This is a 3 by 1. This is a 1 by 3. Those numbers are the same, so we can multiply them. And our resulting matrix is going to be a 3 by 3. This 3 by 3 matrix is going to get its rows from the first matrix, COA, and it's going to get its columns from the second matrix, COA. Interesting. It's my belief that this matrix is completely irrelevant. And the matrix, well, that was my purpose of the problem. My purpose of this problem is to get you to see that B times A has much more meaningful, because this 1 by 1, remember, these things not only have to be the same number, you have to measure the same thing. The number of columns is shares, and the row is cell. Guys, this is meaningless. We can calculate it, we can put numbers in there, but it doesn't mean anything. Now, what if we'd done it the other way, B times A? Well, B is a 1 by 3. A is a 3 by 1. We're going to multiply this out and we're going to get a 1 by 1 matrix. What does this 3 measure in B? What does this columns measure in B? Computer, oil, automobile. What does that 3 measure? Computer, oil, and automobile. So guys, we get a 1 by 1 matrix. What that's going to do is it's going to tell us her total investment, how much her total investment is worth. Okay, so let's work it out that way. So we need to put, I'm just going to be consistent here and put the matrices in as they have. So A is going to be a 3 by 1. So I have 100, 300, and 400. Quit, go back into matrix, go over, let's edit our B. And guys, our B is going to be a 1 by 3. So we have 60, 38, and 17. Okay, let's multiply this together. So we need to go matrix B first, times matrix A second. And we find out that her total investment is worth $33,200. Okay. Well, guys, long video, but I'm done.